Okay, so here we are. This is intro. Is that large enough? Yes? Intro stats. Love the subject. Okay, so, well, first of all, let me tell you, it's always a good idea, I think, anytime you're going to learn something new, you should ask yourself, why am I bothering learning this, okay? And I recognize the true answer for most of you is that it fulfills a GE requirement, and that's fine, but why do you think UCLA has made this a GE? Well, that's the point of what I'm trying to say here. Okay, so why do we study statistics? Okay, so I will answer this and I will say we study statistics to gain a better understanding of the world around us. Okay. And this can honestly be said about many subjects. You study history to gain a better understanding of the world. You study chemistry or physics or whatever it might be. Even literature. You're trying to understand something about the world, whether it be people or things in science. So specifically, statistics allows us to make conclusions from limited data. Okay. So let me tell you what I mean by making conclusions from limited data. Okay, so a lot of times in science, if we do science to try to learn more stuff, and you're going to start off with some kind of research question. Okay, so science, or whatever it might be, any kind of science really, often begins with some kind of research question. A research question being a question that requires a little bit of research. It can't just be, a philosophical question where you contemplate things and you just think about the answer. But this is something where you're going to gather some evidence. Okay. And anytime you have a research question, an important part to understand is who the relevant population is for that question, okay? So every question has a relevant population, okay? And what I mean by that is that the population is the group of people or things or whatever it is that you're studying that could potentially be used to help answer your research question. Okay? So this is everyone or everything that is possibly relevant to helping answer their question. Okay? So this is okay, so let's say you are working at a pharmaceutical company, okay, and you're trying out some new experimental drug, or you're trying to develop a new drug that will, I don't know, fight lung cancer or something like that, okay? So let's say you have, so some new, I don't know how you feel about the pharmaceutical industry, but okay, so let's say you have, you're developing a drug okay, and you have this question, is this drug effective at, we'll just say, fighting lung cancer? Okay, is this drug effective at fighting lung cancer? So in this question, who is our relevant population? Yeah.
Things that can get lung cancer.
Things that can get lung cancer. Okay, so our population will be everyone, we'll say that has lung cancer, okay? Because as it's phrased, we're not looking at preventative medicine. Like, we're not looking at it'd be awesome if there was a lung cancer vaccine, but this is not what, we'll say this is for people who have lung cancer. So everyone that has lung cancer, and perhaps we could extend this to everything that has lung cancer. So oftentimes before they do testing on humans, they might do tests on mice or something that have developed lung cancer, and that's a whole nother system where you have to find animals that, or give them lung cancer through, different means and whatnot. But we'll just say, the population is everyone that has lung cancer. And perhaps because of research constraints and whatever it might be, maybe you're going to be limited to people in the US or limited to people in a certain geographic area. And the hope would be that the people that you are studying would resemble the people in the general population as well. Okay. Okay. And so we have a few few ideas here, in that in general, whenever we're talking about a population, the population is too big to be studied directly. Okay. And this is kind of the key things of why we have statistics as a subject. So in general, the population is too large to be studied directly. Okay, so if we're talking about everyone that has lung cancer, there are just too many people, okay? And the population is not always fully defined or known, right? There could be people who have lung cancer and we're not even aware of it, okay? Those people might not even be aware that they have lung cancer, but they are potentially someone that we would want to study, okay? And so when we're talking about this population, yeah, ideally we would love to look at everyone in the population, but it's just too big or too hard to obtain directly, okay? And so instead of studying the population, we will study a sample. Okay, so I'm going to flip the slide. Is that good with everybody? Yeah? Okay. Yes?
Do you separately publish the slides, or it's just included in the video?
So yes, I will post the video, and I will also post the slides. I'll throw them into a PDF, and they'll be available there also. Okay, so I try to do as much as I can to help you guys out, right? I know some of you learn best by taking notes and following along. Okay, and that's why I write. I know it slows down the pace of the course a little bit, but it's for those of you who are trying to write. Some of you just want to sit back and watch and pay attention, and you learn better that way, totally fine. The notes will be available for you after the class is over, okay? Just, I don't think anybody learns best by sleeping, so, but some of you use that approach in class, okay? But it's the first week of class, and all of you guys are, I'm sure, full of great ambition at the start of the quarter. Okay, what was I saying? I said the population is too big to be studied directly, so instead of studying the population, we take a selection of people or subjects or whatever we're talking about. People or subjects, and study that. Okay? And so that select group is called the sample. And so, kind of just to illustrate this, so here's this big, this is supposed to be a big thing called the population. Again, we're going to just write too big. And so what we do is we're just going to draw a tiny little piece, okay? We're going to magnify that. Okay, this is our sample, okay? We're gonna, we observe this thing. Okay, and based on what we see in the sample, we will try to make conclusions about the population. So that process of taking the sample and then making conclusions about the population, this is called inference, okay? Or we might say this is statistical inference. Okay, and that's what I mean by making conclusions from limited data. So we're just taking a small piece out of the population, we observe this, and based on that, we try to make conclusions. Now, if we want our conclusions to be valid, conclusions about the population to be valid, our samples need to be representative of the population, okay? And if our sample is not representative, then we would say this is a biased sample, okay? and we experienced some issues with this, right? Recently with the presidential election, okay, based on the polling and the samples that were selected prior to the election, you know, that it looked like the outcome was going to go a certain way, and then on election day, when the true population is revealed, when we actually get all the votes from all the different people, we actually see what the population looks like. So, you know, the whole idea with polling was we're not going to survey all however 100 millions of Americans there are, or voters there are, but, you know, you take a sample of maybe 1,000 voters or something like that. Based on the responses you get in those 1,000 or so voters, you're trying to make a conclusion about how, let's say, the state of Florida is going to vote or something like that. And then you say, well, this is what my sample looks like, then this is what I think Florida is going to look like, okay? But then on election day, you find out the true population, okay? So that's a situation where you actually do get to eventually study the population directly, but it's very expensive to run an election and you only do it once. And so everything before that is based on samples, okay? And there's a lot of questions about, you know, what went wrong with the sampling and this and that, and there's different theories as to what might have gone wrong, but there's also what we will see in statistics is that even if there was, quote, nothing wrong with the samples, just sometimes the data that you get in samples, because of the random nature of sampling, will not always be representative of the population, okay? So anyway, so this is always going to be an issue in all of your research, or if you're going to do any kind of surveying and sampling. We want the samples to be representative of the population. It is actually very difficult to pull that off, okay? But we'll just talk about, you know, some ideas that go into getting a representative sample. So let me just say, in reality. So in truth, it is quite challenging to get a representative sample. Okay. There's a method that should give you representative samples in the long run, but it's not guaranteed to do so. Okay, so one method that should produce representative samples is not guaranteed to do so. Simple random sampling, or we might call this SRS. Okay, simple random sampling. Okay, and in simple random sampling, you start off with what we call a sampling frame. Okay, a sampling frame is ideally a list of every single person or everyone in the population. Okay. Or I should say a list of everyone. And that's the hard part, okay? Getting a list of everyone in the population, this is difficult, right? If I said, I need a sampling frame for the city of Los Angeles, can you do it? What could we use as kind of a starting point? The census, okay. So if the census were to share their information with us, they're like at a personal level, which they won't, but you know, if they did, you know, we could get some information, but that is already 7 years old. That data is coming from 2010, and I imagine many of you did not live in Los Angeles in 2010. Okay, now some of you grew up in Los Angeles spent your whole time, but many of you got here just a few years ago. Okay, and so none of those people would be included. All right, and then people have been born, people have died, things like that. So it's rather hard. Okay, phone books, nobody's listed in the phone book anymore, right? And who here is listed in a phone book? No one, right? Maybe if the phone companies would share their data, we might be able to get kind of every cell phone that's pinged a Los Angeles located tower. But you know, it's close to impossible to do, right? And then you have a lot of people who are hard to access, right? You have people who don't have permanent addresses or even mailing addresses. We can think of different population or groups that are, quote, off the grid. These are, you know, if they're not included in your sampling frame, they will not be included in your sample. So whatever deficiencies you have in your sampling frame, those will be the same deficiencies that will exist in your sample, okay? So, but anyway, you begin with a sampling frame, and then as it's called simple random sampling because the process just says, you know, using a random system, so whether that's putting everyone's name on a slip of paper and throwing it into a hat, which works just fine, or drawing ping pong balls out of a thing also works fine, or using a random number generating system from you know, a computer or something, depending on your random number generating system, that can also work just fine. So using a random system, select individuals one at a time from the sampling frame. Okay, and if you do that, then you will get a simple random sample. Okay, and so here are some properties, is that every single person in the sampling frame has an equal chance of being selected. Okay, and every single possible sample has an equal chance of being selected. Okay, and what I mean by every single possible sample has an equal chance of being selected, think of a lotto ticket. Okay, so when you play the lotto, which I don't recommend, but you know, if you were to if you watch the numbers being drawn, oftentimes they're on little ping pong balls in some kind of tumbler, okay, and they just draw them out one by one. That's a simple random sample taken from the population of however you know, I don't know how many numbers are available. Let's say 60 numbers. Okay, they have 60 numbers. That's the population, and they're just drawing, let's say, 6 numbers out of there. Okay. Every combination, every possible combination of 6 numbers has an equal chance of being selected. 1, 2, 3, 4, 5, 6 has an equal chance of selection as 13, 25, 27, 42, 40, whatever, 6 numbers, okay? Any grouping of 6 numbers, they all have an equal chance of being selected, and that is the properties of a simple random sample, okay? Okay, so far so good? Everybody's able to read everything on the screen? We're okay there? Okay, great. All right, let me just give you kind of a brief overview of the course, some kind of thematic parts of the course, so that when I cover a topic, I don't know if you guys will refer back to this, but you can kind of see how this fits in with the different parts of the class, okay? So the first couple weeks, or the first few weeks, will be spent on this topic of descriptive statistics. Okay, and listed under descriptive statistics, we're going to just learn the big picture idea here is we're going to learn how to summarize data using just a few numbers or pictures. A few values or pictures. Okay, and this also includes looking at, well, different kinds of data. So that's descriptive statistics, and this will take us through basically midterm 1 covers descriptive statistics. Okay, and then after midterm 1, we're going to start talking about probability. Okay, so probability starts kind of this side of a little bit of theoretical stuff that we have to think about. Okay, so probability, this tells us how likely or unlikely something is to happen. How likely or unlikely something is. And probability, we often, when we start off, we start talking about like coin flips, right? That we say the coin flip has a 0.5 probability of landing heads. No biggie, okay? But then we complicate things, we get things a little bit more advanced. We start talking about probability distributions and random variables, but I'll just write probability distributions, okay? And this is just makes the concepts in probability and further extends them. And after probability distributions, we get to something called sampling distributions. Okay, and with a sampling distribution, the idea there is it's still a concept very closely related to probability, but this will tell us how likely or unlikely certain samples of data are. Okay? Okay, so that's coming in through the probability side, and that will take us through midterm 2. Okay, and then so we take our understanding of descriptive statistics, and then our understanding of how likely or unlikely certain samples are, and we combine this into statistical inference. And the idea behind statistical inference is we're going to look at data that we've collected and described. We will also look at the sampling distributions and see how likely or unlikely this is, and use those two parts to start making conclusions. Okay? We take samples of data and our understanding of their likelihood or probability. And use that to make conclusions. So that will be the last leg of the course. Okay, and that will take us through the final exam. Okay, I am looking forward to a great quarter with you guys. We'll see you guys on Wednesday. Please go to your discussion section tomorrow in class. So see you guys in a little bit.